For at least once in a lifetime, we all get these questions in our minds. What exactly is the universe? Did it always exist like this? If not, how was everything created? And I'm not talking just about the planet Earth, but the whole solar system, our sun, and billions of such suns in the night sky, the Milky Way galaxy, and millions of such galaxies. But most of us stopped finding answers to these questions because it seemed too complicated for our brains to comprehend. However, not everyone moved on. Scientists such as Einstein, Edwin Hubble, Hawkings, Lemaître kept working on theories to find out how everything started and became what it is today, the process which is now known as the Big Bang. In today's video, we have carefully curated and made these findings very simple for you to understand. The Big Bang is the prevailing cosmological model that explains the origins and evolution of the universe. According to this theory, the universe began as a singularity, that is an infinitely hot and dense point approximately 13.8 billion years ago. In the following moments, the universe rapidly expanded and cooled, forming the building blocks for galaxies, stars, and planets. The concept of the Big Bang was first introduced by Belgian physicist Georges Lemaître in the 1920s. Lemaître observed that the universe appeared to be expanding, which implied that it had a beginning and everything started from an infinitely dense singularity. However, it was not until the 1960s that the theory gained widespread acceptance among cosmologists after the discovery of the cosmic microwave background radiation, that is the CMB. This radiation is the afterglow of the Big Bang, and it was first discovered in 1964 by Arnaud Penzias and Robert Wilson. The CMB is a faint glow of radiation that permeates the entire universe and is thought to be the residual heat left over from the Big Bang. The Big Bang theory is supported by a vast array of observations and experimental data. One of the most compelling pieces of evidence is the observed redshift of light from distant galaxies. This redshift is caused by the Doppler effect, which occurs when an object is moving away from the observer. You must know that red light has the longest wavelength among the visible spectrum of light. This is why this color is used for warning and signaling. The same concept applies to the light coming from distant galaxies. The farther away a galaxy is from us, the more its light is redshifted or stretched to longer wavelengths, indicating that it is moving away from us. This observation is consistent with the idea that the universe is indeed expanding and that galaxies are moving away from each other. The Big Bang theory also explains the abundance of light elements such as hydrogen and helium in the universe. These elements were formed during the first few minutes after the Big Bang, when the universe was hot and dense enough for nuclear fusion to occur. As the universe expanded and cooled, these elements formed the building blocks for the formation of stars and galaxies. The formation of stars and further planets has been explained in our earlier video, which you can watch from our channel. So how did the universe expand according to the Big Bang theory? Well, the early universe was a hot and dense place, and it took hundreds of millions of years for it to cool enough for atoms to form. As the universe further expanded, matters clumped together to form galaxies, stars, and planets. As explained earlier, the evolution of these structures is driven by gravity, which causes matter to collapse and form denser regions. Over billions of years, galaxies merged and stars exploded, creating the heavier elements necessary for life to exist. The Big Bang theory has also provided insights into the age of the universe. Scientists have estimated the age of the universe using a variety of methods, including the measurement of the CMB or the cosmic microwave radiation background and the observed redshift of distant galaxies. These estimates suggest that the universe is approximately 13.8 billion years old. According to this theory, the universe is still expanding, which means as you complete watching this video, the universe has already become a bit larger than earlier. Fascinating, isn't it? However, this expansion is much slower than the initial days of the Big Bang. One of the major implications of the Big Bang theory is that the universe is not eternal, but rather had a beginning. This idea is supported by the second law of thermodynamics, which states that the universe is gradually moving towards a state of maximum entropy or disorder. If the universe had always existed, it would have already reached this state, which implies that it had a beginning. While the Big Bang theory has been successful in explaining many aspects of the universe's evolution, there are still some unanswered questions. For example, the theory cannot explain the observed flatness and homogeneity of the universe, known as the horizon problem. The horizon problem is centered around the idea that if universe reached the present stage because of expansion, then different regions of it should have different cosmic microwave background radiation. However, that is not the case, and the observation of different regions of universe reveal the homogeneity in the CMB, implying that they must have formed together to come into thermal equilibrium. Additionally, scientists are still trying to understand the nature of dark matter and dark energy, which are believed to make up the majority of the universe's mass energy. Despite these challenges, the Big Bang theory has revolutionized our understanding of the universe, and it remains one of the most widely accepted scientific theories. It has provided insights into the origins and evolution of the universe, and it continues to be an active area of research in cosmology.